Hello and welcome to another video in this Basics of Geometry series. Today we are going to be talking about a specific type of problem which often occurs across the multiple subtopics and shapes in geometry, which is the shortest distance problems. So questions will often ask you to find out shortest distance and minimum distance between 2 points. And it's an axiom. It's a self-evident truth that in geometry, minimum distance between 2 points is always going to be a straight line. So almost always shortest distance questions is about measuring the length of a straight line. Now that's very simple to understand when it comes to 2D geometry. But why I'm talking about this particular type of question specifically in this video is because this is very difficult to understand in 3 dimensions. In 3-dimensional shapes, to find out minimum distance between 2 points, people often struggle. And it's a very common kind of a trap or common kind of a tricky question that paper setters put in a lot of examinations like NMAT and ZAT and CAT and GRE. So let's understand how to interpret the shortest distance between 2 points as a straight line when it comes to 3D shapes. And for that, the thing that I've spoken about in the video before this, which is the importance of visualization, is going to be extremely useful and handy. So to understand how to solve these kind of problems, we have to understand that every 3D shape is made up of a transformation from a 2D shape. For example, let's say that I have this rectangle. Now imagine if you roll this rectangle up, right? If you roll it up into a circle, like the top part into a circle where this end is going to meet this end from both sides, then the rolled up rectangle will be a cylinder. So if you cut open a cylinder and you make it flat, it becomes a rectangle. Similarly, imagine if I fold this rectangle. Let's say that this rectangle has a length of 3 units. And I fold this rectangle at a distance of every 1 unit. Or let me, for the sake of convenience, let's consider this to be a 4-unit length rectangle. And if I make folds at every 1 unit distance, then eventually this is going to be folded to make a rectangular parallelepiped or a cuboid. So this kind of visualization of being able to transform a 2D shape into a 3D shape, or to transform a 3D shape into a 2D shape by cutting it down and making it flat, becomes extremely important in solving shortest distance between 2 points questions. So how is this going to be handy? So let me explain with an example. Let's say that there is a cuboid shape like this. So suppose I'm going to draw this a bit slowly and a bit in a rough kind of a sense so that I don't waste too much of time in the pursuit of perfection. Okay. So I hope all of you can visualize how a cuboid looks like. Like this is a cuboid which is standing on this base. Now, if I ask you to find out the shortest distance that you can take on the surface of this cuboid from this point to this point. Through the body of the cuboid, it's very easy. That's going to be the body diagonal of the cuboid. But suppose you cannot go inside the cuboid on the surface, you have to travel from here to here. Then how will you do that? You will cut this cuboid open, make it flat. And once you make it flat, it's going to be this point is going to come here. This point is going to exist here, or rather here. So this straight line then becomes the shortest distance. So instead of trying to draw a straight line in a 3D sense from here to here, which is impossible to draw, you would rather convert it into a 2D shape and then draw a straight line, because a straight line is going to be a 2-dimensional shape, which is easier to represent on a 2D plane rather than getting a sense of understanding as to how to represent the 2D straight line in a 3D shape. So like this, you'll find several times questions in 3-dimensional objects and shapes, and you have to find the minimum distance or shortest distance between 2 points. Make sure that when you're solving such questions, you're cutting open the 3D shape and laying it flat on a table in front of you, and then draw straight lines between points. Calculate the length of those straight lines, and that will represent the answers to such questions. And doing this requires our capability to visualize, to be able to understand how to transform a 3D shape into a 2D shape. So that is something probably that you can work upon in order to get better at questions of this type. Thank you.